Hello students. So I hope for all of you the preparations are going well. In this video we will be discussing NEET PYQs from 2016 to 2023 for chapter Electrostats. Right now in this chapter or in this video what I have done is I have divided this video into two parts. In the first part we will be discussing your questions related to charge and electric field, and in the second part we will be discussing questions related to your potential, right, electric potential. So let us start one by one. We will see all the questions. So our first question says an electric dipole is placed at an angle of 30 degree with an electric field intensity 2 into 10 power 5 Newton per Coulomb. Okay. So let's draw the situation. We have electric field is there. I am taking it horizontal. Electric field 2 into 10 power 5 Newton per Coulomb, right? And dipole is placed at an angle of 30 degree. So let me draw this. Dipole is, let's say dipole is like this, minus q and plus q. The angle is 30 degree. Well and good. This is a dipole. Next it says it experiences a torque equals to 4 Newton meter. Torque is 4 Newton meter. The charge on the dipole, if the dipole length is 2 centimeter, they are asking us charge q on the charge on the particles if the length is 2 centimeter. Yeah. How do we calculate? Torque is given to us. Torque is given to us 4 Newton meter. What is torque on a dipole? Torque on a dipole is written as, torque is given as P cross E, right? P is our dipole moment. So we can write down torque is equals to P E sin theta. Over here we know P value is what? Q into L. P value is, that is dipole moment is Q into L. So let us substitute tau is equals to QLE sin theta. One by one if we write down the value. So torque is 4 QL. L is your 2 centimeter, so which we can write as 2 into 10 power minus 2. Electric field 2 into 10 power 5 sin theta, that is sin 30, which will be your 1 by 2. So what we have, it cancels out 4, and ultimately we will be having Q will be equals to 2 into, we'll have over here 10 power minus 2, 10 power 5, that will be 10 power 3. It goes into denominator and comes over here 10 power minus 3. 2 into 10 power minus 3 coulomb, which we can write as what? Which we can write as Q is equals to 2 millicoulomb. 2 millicoulomb. So our option is, option number B is our correct answer, right? Yeah. Next we have a theoretical question. We have, if integral E dot ds, if integral E dot ds is equals to 0. What is integral E dot ds? This is basically your electric flux. No, this is electric flux. So electric flux they have given is 0. Then now what do we know about electric flux? Electric flux integral E dot ds is given as basically Q in by epsilon naught, Gauss law, right? This is our Gauss law. So this is equals to Q enclosed by epsilon naught. Now they have given us 4 options. Let us check one by one. The electric field inside the surface and on it is 0. Not necessarily, electric field is not necessarily 0. Let's see second option. The electric field inside the surface is necessarily uniform. This is also incorrect. C option, it says the number of flux lines entering the surface must be equal to number of flux line leaving the surface. Yes, this is a right statement, because what is flux telling us? Flux tells us basically the number of lines crossing the surface. Number of lines crossing the surface, and this is given for a closed surface. So if the flux is 0, that implies two things. You can answer it, flux will be 0 when the total charge which is present inside is 0, or in lines terms, if I have to say, basically the number of lines which are entering is equals to number of lines which are exiting, then your flux will be 0, right? So our option C is correct. What is our option D? All charges must necessarily be outside the surface. No, this is also a wrong statement. Why? I'll show you. Let's suppose the surface is there, closed surface, and we have a dipole here, minus q plus q. Now we do have charges here. We do have charges. Net charge is 0 over here. So we can't say that all charges are present outside. Charges are present over here, but over here net charge is 0, and therefore your flux is 0. right? So our for this the answer will be C option. Fine. Yeah. So our next question we have is the ratio of Coulomb's electrostatic force to the gravitational force between an electron and proton separated by some distance is 2.4 into 10 power 39, right? So what we have is, let's say an electron is there, a proton is there, it's visible to you guys. Electron is there, proton is there, and they are separated by some distance. The ratio of electric force to gravitational force is given to you 2.4 into 10 power 39. Okay. Next it says the ratio of proportionality constant K to the gravitational constant G is nearly. They are asking us ratio of this F by G nearly. Now please understand one thing. If you look at the four options that are given to you over here, 10 power 20, 10 power 30, 10 power 40 and 10 power 10. If you notice, the four options are not very near to each other. They are not like that you have 10 power 20, 10 power 21, 10 power 22, 10 power 19. No, options are very clearly distinct with each other. So it will be best that we do a rough calculation. Don't get involved into the calculation too much. Don't try to calculate precisely. If we do it rough calculation also, our job will be done for this question, right? How? Let us see. So they are asking us the ratio of K by G. What is it given? F electric by Fg is given to us 2.4 into 10 power 9. What is our force electric? Force electric between them, a negative charge, a positive charge, it will be attractive, and it is given as K Q square. I am writing Q square because the magnitude of charge is same. K Q square by R square divided by gravitational force will be your G m1, that is mass of electron, m mass of proton by R square. R square cancels out. So we have, this is equals to this value. So we have KQ square by GME MP is equals to 2.4 into 10 power 39. Fine. So over here I can write K by G is equals to 2.4 into 10 power 39 into MEMP. I can take it over here, MEMP by Q square, right? This is what we have got it. Now let's substitute all the values. 2.4 into 10 power 39. Mass of electron is 9.1 into 10 power minus 31. Mass of proton is 1.67 into 10 power minus 27 divided by Q square. Q square will be 1.6 into 10 power minus 19 whole square. That means 1.6 square into 10 power minus 19 square will again become your 10 power minus 38. Now what you do is you solve these terms. Let us solve these terms because we want answers according to the option without getting into too much calculation of it. So what can we write it? Let us see. This is 10 power 39. This is 10 power minus 38. So it will become your 10 power. What can we write this one? 10 power 77, right? Into this is your 10 power minus 31, 10 power minus 27. So we will get over here 7, 8 and 10 power minus 58. I hope this point is clear. Now if you notice carefully how much we will be getting this answer will come around, your 10 power 20. This will come around 10 power 20. So we didn't go into too much calculation just because the options, first we check the options, that options are very distinct with each other. So this will be around your 10 power 20. So option number A, option number 1 is our correct answer. Fine, let us move ahead. Yeah, next question what we have is 2 point charges minus q and plus q are placed at a distance L. Okay, minus q plus q are placed at a distance of L as shown in figure. The magnitude of the electric field intensity at a distance r, where r is very very large as compared to L. That means basically this is a dipole. This is our dipole. This is giving us the situation is of dipole. Now they have not given whether we have to find out at axial point or equatorial point, which is not required also. They are just asking the proportionality. So let us see. I will write both the results for you guys. Electric field at axial point. Let's suppose some point we are talking about axial point. So electric field at axial point due to a dipole is what? For this result, for short dipole, it is given as 2 kp by r cube. Well and good. Next, electric field at equatorial point is given as what? Kp by r cube. It is given as Kp by r cube. Now, in both the results, you can see very clearly that electric field is proportional to 1 by r cube. Electric field is proportional to 1 by r cube. So, our option will be option number 1. Capital is given, it's fine. And I have taken small, generally we take it small. So, it is basically 1 by r cube, option number 1. Yeah. So, our next question is, the acceleration of an electron due to mutual attraction between electron and a proton when they are 1.6 angstrom apart is fine. So, electron is there, proton is there, and they are separated by a distance of 1.6 angstrom. Fine. They are asking us acceleration, mass of electron is given, charge is given, and k value is given. Fine. Now, what is acceleration? Why will electron experience acceleration? So, acceleration is basically force by mass. Which force? They will experience your attractive electric force. This is negative, this is positive charge. So, they will experience force. So, let us write down what is our electric force. Electric force between the two electron and proton will be K Q1 Q2. Now, we know that charge on electron and proton magnitude wise is same only. You know? So, we can write KQ square by R square, and acceleration will be F by m. Let us write it. So, it becomes kq square by mr square. I'll substitute the terms. K is 9 into 10 power 9. Q square 1.6 into 10 power minus 19 square. So, 1.6 square into 10 power minus 38 divided by mass is given to us in question 9 into 10 power minus 31 into r square. But this 1.6 angstrom is basically 1.6 into 10 power minus 10 and 1.6 into 10 power minus 10. So, if we square it, it will come out 1.6 square into 10 power minus 20. What we have now? 9 and 9 cancel, 1.6 square goes. So, this becomes 10 power 12, sorry 10 power, this is 40, and this will become 10 power 60 into 10 power minus 38. How much are we getting? 10 power 22 meter per second square, right? Which option we have? Option number D. Option number D is our correct answer. Next, a theoretical question, a factual question. Polar molecules are the molecules having zero dipole moment, acquire a dipole moment only in the presence of electric field due to displacement of charges, acquire a dipole moment only when magnetic field is present, and fourth, having a permanent electric dipole moment. Fourth is the correct answer, right? Fourth option. It's a factual, it's a something that we should know it. So, polar molecules definition is which have permanent electric dipole moment. Fine. Let us see next. Okay. Our next question says, a spherical conductor of radius 10 centimeter has a charge 3.2 into 10 power minus 7 coulomb. Spherical conductor, radius is 10 centimeter and charge is 3.2 into 10 power minus 7 coulomb. This is what is given. Yes. What is the magnitude of electric field at a point 15 centimeter from the center of the sphere? Okay, K value is given, 1 by 4 pi epsilon naught value is given. 15 centimeter will be where? Outside point. Obviously, 15 centimeter will be outside points. And for outside point, what is the electric field due to a shell, due to a sphere? Whether hollow or solid, it is electric field for outside point is given as KQ by R square. Right. So, let us write down. So, E is equals to K. K value is 9 into 10 power 9. Q value. Q is 3.2 into 10 power minus 7 by R square. If we see 15 centimeter, that means 15 into 10 power minus 2. So, we can write it. So, this will be your 15 into 10 power minus 2 square. If we do it, it becomes your 225 into 10 power minus 4. Let's see it. E is equals to 9 into 32 by 225 into this will be your 10 power 8 into 10 power minus 7 by 10 power minus 4. So, E value, when we solve all this, we will get it over here. this will be 10 power 1 and this goes so up 10 power 5. And when we will solve this 9 into 32 by 225, we will get it 1.28, right? 1.28 into 10 power 5 Newton per Coulomb. So this is our answer, right? Yeah. The question we have is, it says 2-point charges A and B having charges plus Q and minus Q respectively. Fine. This is A and B plus Q and minus Q respectively are placed at a certain distance apart and force acting between them is F. Fine. Let's say that distance is R. They are opposite charges, so it will be attractive force F is there, right? How much will be the force? Right now, if I have to write force, F will be basically kq square by r square. Magnitude I am writing. Magnitude will be kq square by r square. Fine. Next, if 25% charge of A is transferred to B, the force between the charges becomes, okay, 25% of the charge. 25% of this, 25% of Q will be how much? 25% of Q will be your 1 by 4. That means your Q by 4 is transferred. So from Q, if we take Q by 4, how much will be left over? 3Q by 4, right? And this Q by 4 which is being taken, this Q by 4 is given to minus Q. So how much it will get? Minus Q plus Q by 4. This will come out minus 3Q by 4. I hope this point is clear. So this is the charge on A afterwards. This is the charge on B afterwards. Let's see. So on A we have charge 3Q by 4. And on B we have charge minus 3Q by 4. Separation is still R only. Let us write down the new force. What is the new force? So let's call the force as F dash. Let's call the force as F dash. So F dash will be KQ square. If we square this, again magnitude wise both are same. Magnitude wise both are same. 3Q by 4, 3Q by 4. Magnitude wise. So KQ square, if we do it, it will come out to be 9 by 16 Q square by R square. Right? Very clearly you can see KQ square by R square is F. So we can write F dash is equals to 9 by 16 F. This will be our answer. Which option we have? Option C. Option C is our correct answer. Fine. Let's look at the next question. Yeah. So question is, two parallel infinite line charges with linear charge density plus lambda coulomb per meter and minus lambda coulomb per meter. Two line charges are there. One is having charge density plus lambda, another is having charge density minus lambda. They are placed at a distance of 2r. They are placed at a distance of 2r. What is the electric field midway between the two line charges? Okay, well and good. So they are asking us electric field. First of all, simple formula for what is electric field due to a line charge. Due to a line charge, it is given as electric field is 2k lambda by r. Electric field is given as 2k lambda by r. So this we can write as k is 4 pi epsilon naught, which therefore will give us lambda by 2 pi epsilon naught r. This is the electric field due to a line charge. If it is positive, it will be away from the charge, and if it is negative, it will be towards the charge. Now let us write down. So over here we want to find out at P point. This is your positive charge, that means it will be away. I am calling this as 1 and this is 2. So due to this it will be away, it will be E1, and due to this one it will be towards the charge, because this is negative. So this is we are calling as E2. Both are coming in same direction. So net electric field E net will be what? E1 plus E2, which will be towards the negative line wire. Now let us write down E1 and E2. E1 is due to positive 1, it will be lambda by 2 pi epsilon naught, separation is r over here because it is mid, plus lambda by 2 pi epsilon naught r. Now some may get confused, sir, why you took lambda, why not minus lambda? Because I already considered the effect of the negative charge, which is towards the line wire. That's why I did E1 plus E2. So that effect is already been considered. That's why we are adding up the electric field. So finally what we'll get it, when we will add up, we'll get over here 1 by 2 plus 1 by 2, 1. So we'll have lambda by pi epsilon naught r towards negative. It will be towards negative line wire. So our answer is, they are only asking the magnitude, which will be lambda by pi epsilon naught r. Option number 3. Option number 3 is our correct answer. Okay. Next, a theoretical question. Some concepts and formulas we will need over here. What we have? a hollow metal sphere of radius r is uniformly charged. Hollow sphere is there. The electric field due to the sphere at a distance r from the center is, okay, hollow sphere is there, radius is r, some uniformly charged distributed, let's say charge is q. Now what is the electric field as it goes from center? This, let's say, is point P, which is at a distance of small r. Now we know for hollow sphere, for r less than capital R less than capital R means inside points. For r less than capital R, electric field is 0. And for r less than capital R, that means it will be inside point somewhere over here. It is 0 for hollow sphere. It is your 0 only. Next, for r greater than capital R, electric field is given as kq by r square. Right? Now you can see the option. Which option says this? 0 as r increases for r less than capital R, that means small r less than capital R. That means your option 2 and 3 both are saying this. Next, what it says is, now as we go outside, E is inversely proportional to r square. As you move ahead, that means as you move away from the center, even outside points. So for outside points, as you move, E is inversely proportional to r square. That means your E value will decrease. So r will decreases as r increases for r greater than capital R. So for r greater than capital R, your electric field will decrease. Which option it is? Option number second. Option number second is giving us that. Option number 3 says that it increases. No, as the point will be away from the center, electric field will decrease, as you can see very clearly in the result. Fine, let's look at next question. Yeah. So the question we have is, next question, it says a sphere encloses an electric dipole with charges plus minus 3 into 10 power minus 6 coulomb. Sphere is there and a dipole is there, minus q plus q, है ना? Sphere is enclosing a dipole. So you have like this, okay, dipole will be there. Now they have given us charge. They are asking us what is the total electric flux through the sphere. What is our flux? What is our electric flux? Gauss law says electric flux is equals to q in by epsilon naught. Now if you will notice over here, what we have is, inside, what is the net charge? Net charge is 0. Charges are there, but this is minus q plus q, equal in magnitude, opposite in nature. That means q in is 0. Therefore, your flux will also be 0. Your flux will be 0. So which option we have? Option number 2 is our correct answer, right? Fine. Yeah. So our question is, an electron falls from rest through a vertical distance h in a uniform and vertically upward directed electric field. Okay, so electric field is given to us, upwardly directed. Let's say it is upward, E, and it's visible, visible. And it says the electron is falling through a distance of h. It comes down a distance of h from here to here. Okay. Next it says the direction of electric field is now reversed, keeping its magnitude the same. A proton is allowed to fall from rest in through the same vertical distance. Fine. Now the direction of electric field is reversed. That means earlier it was upward. Now we have made it downward. Fine. And a proton is made to fall now with the same distance h. Right. They are asking us the time fall of the electron in comparison to the time fall of the proton is smaller, 5 times greater, 10 times greater, equal. Let us see. So this question basically somewhat our knowledge of kinematics will be used. What is our motion? In motion under gravity we studied something. Both of them are starting from rest. That means they are released. Hai na? So we studied, if you people remember, if a particle is dropped from a height h, the time taken to fall down is root over 2h by g. I hope this point is okay with you all. So this will be using result, this result will be needing. Now it is root over 2h by g. Over here we don't have g. In this case we don't have g. So for this, what can I replace it? If a particle is dropping through a height h, your time can be written as root over 2h by a. Now in this case, if you notice, in this case what will happen, this is electron negatively charged, the force will be acting downward direction, QE, opposite to the electric field. In this case also it will be downward direction, QE, but your time is inversely proportional to root a, because height is same for both of them, so time is inversely proportional to root a. Let us check in which case acceleration is more or less. So for acceleration of electron, if I have to write, it will be QE by mass of electron. Acceleration of proton will be written as QE by mass of proton. As we know very well that mass of proton is larger as compared to mass of electron. Mass of proton is more as compared to mass of electron. Therefore, we can write your acceleration of proton will be less than acceleration of electron, right? Step 1, step 2. Now, once we got the idea about acceleration, we know that time is inversely proportional to root a. That implies if acceleration is less, time will be more. So from this, what can we say? Time taken by proton will be more than time taken by the electron. That implies proton will be taking more time, electron will be taking smaller time. So which option we have? There's no need of your 5 times, 10 times. It is basically time taken by electron will be smaller. You know, this is how we decided. I hope you understood it. Let's move to the next question. Yeah. Next question. Again, it's a question which involves your kinematics. So let us see. A toy car with charge q moves on a frictionless horizontal plane surface under the influence of a uniform electric field E. Well and good. Let us draw the situation. So let's say that toy car is there. We draw it. Okay, it is more like a fish, but okay, fine. So toy car is there, its charge is q, and let's say mass is m. Electric field, it is moving under the effect of electric field. How much will be the force? It is your QE, and what it says is, due to the force q vector E, which is your this only QE, its velocity increases from 0 to 6 meter per second in 1 second. Okay, at t equals to 1 second, it's visible. Visible at t equals to 1 second, your the car gets a speed of 6 meter per second, right? Next it says, at that instant the direction of the field is reversed. Now direction of field is reversed over here. That implies what will happen, beta? QE will start acting backward, and due to that a retardation will come. And this speed will start decreasing. Well and good. That will be same. The retardation, because your acceleration is what? QE by m. They are changing the field, direction of field, charge is same, electric field is same, mass is same. So due to this, the magnitude of the acceleration and retardation is same only. We'll calculate that. Next it says, the car continues to move for 2 more seconds under the influence of this field. The average velocity and average speed of the toy car between 0 to 3 seconds respectively is. Fine. Now let us see. So it will continue to go somewhere over here, and then it will stop. Right? It's visible now. It will stop. And because your QE is continuously acting, it will return over here. And for how much time the journey they are considering? 3 seconds. Now let us first of all break it down and then study. First, over here, if we take a look at this 0 to 1 second journey, in this let us calculate acceleration and the distance traveled. So what will be the acceleration? V is equals to u plus at. So 6 is equals to 0 plus a into 1. That implies acceleration is 6 meter per second square. Well and good. In this, acceleration is 6. That implies for the next part of the journey, when it is retarding, your retardation magnitude will be 6 only. So now this is our first part of the journey. If we calculate the distance, so it will be your what? S is equals to ut plus half at square. U is 0. It starts from rest. So half a is 6 into t square 1. What are we getting? 3 meter. Well and good. That implies it is accelerating for 3 meter. Now next, once we have got the idea that the retardation, so this is first part of the journey, so this is till t equals to 1 second. Now next, if we see what happens, retardation happens. How much is our retardation? Retardation is -6. Why I am taking -6? Because the field is reversed, the magnitude of force remains same, and your acceleration will be QE by m. So basically your magnitude wise it will be 6 only, but it is retardation, that's why I have taken it -6. Fine. So let us see how much time it takes to stop. So what it will be? V is equals to u plus at. That implies 0 is equals to, at this point, at the end of 1 second, how much is the speed it has got? 6 meter per second. So 6 minus 6 into t, sorry, t. So what we get is t is equals to 1 second. That implies for next further 1 second, it will continue its journey. That means 1 second over here, next 1 second, total 2 seconds are gone. How much will be the distance traveled in this part? Let us calculate S2. S2 will be ut minus half at square, because it is retardation. U at this point, how much is our speed? 6 into 1 minus 1 by 2 into 6 into 1 square. What are we getting? 6 minus 3, that is 3 meter. Next part of the journey, again it is 3 meters. So this is your 3 meter and this is also your 3 meter. It has stopped. Over here the speed has become 0. Now, because your force is still acting QE in the backward direction, the car will reverse. Basically, the body, the toy will reverse because force is acting in the backward direction. So the toy will reverse and it will start moving in the backward direction. And over here, now this QE will start acting as the acceleration for it. So for next 1 second, how much is the distance traveled by it? Let us see. Distance traveled by it for the return journey, because they have said for 3 seconds. So 1 second, 2 second gone, left over is 1 second. So S3 is equals to U, which is 0 over here, ut plus half A. Still A is how much? 6 only. 6 into T square, which is 1. So we are left with 3 meter. Well and good. That implies this 3 and then return journey will be again your 3 meter only. Okay, nice. Now let us see what all they are asking. Speed average and average velocity and average speed. Velocity average. What is our velocity average? Total displacement by total time. It went 6 meter ahead, returned back 3 meter back, and 6 meter ahead, 3 meter back. Total displacement will be how much? All this is happening on the straight line. Total displacement is this part. This will be your 3 meter. So we can write down 3 divided by total time is what? 3. So it comes out to be 1 meter per second. Let us write down speed average. So speed average is total distance by total time. Total distance 3, 3, 6. Return journey distance 3. So total is your 9. Total time is 3 seconds. 9 by 3, which is your 3 meter per second. So our answer will be 1 and 3. You check the option, it will be option number B. Option number B is our correct answer, right? I hope you understood it. Let's move to the next question. Yeah. So let us see. The question we have is, suppose the charge of a proton and an electron differs slightly. Presently, what we know, what is our knowledge? What we know is that charge on electron and proton, magnitude wise it is same, that is 1.6 into 10 power minus 19. But in the question they have given us a situation that the charges differ slightly. One of them is E, the other is E plus delta E. So let us say proton has a charge of E and electron has a charge of E plus delta E. That means the difference is of how much? Delta E. The difference is of delta E. Fine. If the net of electrostatic force and gravitational force between two hydrogen atoms. Now let us see hydrogen atom. Ideally, present knowledge, what is our present knowledge say? Or what we know? What we know that hydrogen basically one proton, one electron. So a neutral atom, right? But according to this situation, proton has E and electron has E plus delta E. So in this situation, according to this situation, if one proton and electron is there, the atom will not be neutral. It will have a charge of delta E. E minus of E delta E. Positive, negative, that is fine, but this much charge will be there. Delta E on a hydrogen atom. Similar over here also. So the whole point of this story is that hydrogen atom will have a charge of delta E. Fine. Next it says, so again I am saying, if the net of electrostatic force and gravitational force between two hydrogen atom placed at a distance d is 0, then delta is of the order of, fine. So net of the electrostatic force and gravitational force. Net of electrostatic and gravitational force. What do we know, beta? We know over here that gravitational force will be attractive in nature. This will be your gravitational force because of the masses. Gravitational force acts which will be attractive. Whereas electric force, why electric force is acting between hydrogen atom? Because in the question that they have mentioned that there is a difference in the charge of electron and proton. Due to that, delta E charge is coming on each hydrogen atom. So force electric, force electric. Now what they are mentioning is this, on any one atom net force is 0. Net force will be 0, F net equals to 0. F net will be 0 when F gravitational will be equals to electric. So force gravitational should be equals to force electric in magnitude, then only your it will be net force will be 0. Let us write down. They are asking us this, that delta is of the order of, fine. So 1 minute, I'll write like this, Fe is equals to force gravitational. Force electric, what is our force electric? K Q1 Q2, how much is charge? Delta E. Delta E, that means Q1 Q2 will become delta E square by D square is equals to force gravitational. Force gravitation is how much? G M1 M2. Now for hydrogen atom they have given us 1.6 into 10 power minus 27. In the question they have given 1.67 into 10 power minus 27. So we'll take that 1.67 into 10 power minus 27 square Gm1 M2. So Gm square by again D square, cancels out, fine. Next, so they are asking us delta is of the order of. Now you please see carefully 4 options, the 4 options which are given to you: 10 power minus 23, 10 power minus 37, 10 power minus 47, 10 power minus 20. Again the options are very distinct, the options are very distinct, and anyways they are asking is the order of. So don't get into too much calculation over here, just look at the rough calculation so that we can find out this delta I thing. So over here I can write delta E square is equals to G. How much is G? 6.67 into 10 power minus 11. This is your 1.67 square. This will be 10 power minus 27 square will be 10 power minus 54 divided by, over here K will come, which will be 9 into 10 power 9. This is what we are getting. Let's write it. Delta E square is equals to 6.67. I am keeping all these terms aside. I am focusing on the 10 powers. I am focusing on the 10 powers because we check the options and they are very distinct. So I am checking the 10 powers basically. So it will be proportional to 10 power minus 11. We have 10 power 9 in denominator. Yeah, correct. 10 power 9 in denominator, and we have over here 10 power minus 54. So when we will do it, it will come out to be 10 power minus 74. Right, 10 power minus 20, 10 power minus 54. So we'll get 10 power minus 74. Delta E square is proportional to 10 power minus 74. That means delta E will be proportional to what? 10 power minus 37. Right? Which option we have? Option number B. Option number B is our correct answer. I hope you got it. Right? Let's look at our next question. Yeah. So students, up till now in this video we have discussed questions related to your electric charge and field, right? Now we'll be discussing questions from your electric potential, right? So let us start. So the first question that we have is, it says the electric potential in 10 power 2 volt, that means in 10 power 2 volt, fine, in 10 power 2 volt at point P due to dipole is, what is given to us? A dipole is given to us minus Q plus Q, which is separated by a distance of 6 centimeter, 3 centimeter and 3 centimeter, and point P is present at a distance of 5 centimeter from the center of the dipole. This is what the question is given to us. We are asked to find out potential at point P. Now please be careful with this. Please be careful with the distances over here. Distance between the dipole, distance between the charges is what? Your 6 centimeter, whereas the distance of point P is 5 centimeter. So please don't use our relation of electric potential at axial point due to dipole. What is that relation? Kp by r square. Potential Kp by r square. Please don't use this relation directly. Why I am saying it? Because the distance, your 5 centimeter, is very small. It's less only as compared to this. So basically it is not a short dipole with respect to point P. What we will do now? We will find out individual. We will first find out potential due to this positive charge at point P, find out potential due to negative charge at point P, and then get the net potential. So what can we write? Potential at point P will be, let us name this as 1 and this is 2. Potential at point P will be potential due to charge 1 plus potential due to charge 2. What is it coming? Potential due to charge 1. Potential due to a point charge. What is potential due to a point charge? Potential due to a point charge is kq by r. Potential due to a point charge is kq by r. Let us write it now. So due to this we can write it kq r distance. How much is our r distance? R distance over here, this is your 5, this is 3, so we will be having over here 2 centimeter. It is centimeter. Next, for this, due to -1, how much it will be? The distance is your 5 plus 3 8, so we will get minus of kq by 8. Both of them are in centimeters, so let us simplify this. What we will get it? Kq by, this will be in centimeters, so we'll take 10 power minus 2 common over here. 10 power minus 2, 1 by 2 minus 1 by 8. Let's write it. Kq by, this will be 10 power 2. This will come out to be 6 by 8, 6 by 16, right? 6 by 16 we are getting. This one we can write it as 3 by 8. So how much we get it? Final our answer is V is equals to 3 by 8 kq into 10 power 2. They are asking us this value. So 3 by 8 kq. Option is option number 4. Option number 4 is our correct answer, right? Let's look at next question. Yeah, our question is 6 charges plus q minus q plus q minus q plus q minus q fixed at the corners of a hexagon of side D as shown in figure. The work done in bringing charge q naught to the center of the hexagon from infinity is. Fine, hexagon is given to us. So this is what we have, and the charges that are given to us is plus q minus q plus q minus q plus q minus q. Fine. Now they are saying a charge is brought q naught from infinity to the center point over here. What is the work done? How do we write it? Work done will be change in potential energy. Work done can be written as change in potential energy, and change in potential energy can be written as your q into change in potential. I hope this point is clear, which we can write as, so q is how much, which charge is being moved? Q naught. So this becomes q naught V final minus V initial. From infinity, that means initial, obviously potential is 0. Now let us look at final, V final, final potential. At this point, if you will notice carefully, you have, due to this, let us call this distance, that is distance of the vertex from the center, as r. So you will have potential due to this charge as kq by r. Due to this one it will be minus kq by r. Then due to this charge it will be plus kq by r, minus kq by r, plus kq by r, minus kq by r. What is the final potential? Potential at the center point is 0. So this q naught is brought from 0 potential point again to a 0 potential point. That implies this is also 0. So what are we getting? Work done is equals to 0. Work done is 0. Our answer is first option, right? Work done will be 0. I hope you got it, how we solved this. Yeah. A third question. Let's see. It says two hollow conducting spheres of radii r1 and r2. Hollow conducting sphere. This one is radii r1, this one is radii r2. Okay, r1 is given to us more than r2. R1 is more larger as compared to r2. Have equal charges. This is also having charge q. This is also having charge q only. The total charge is q. The potential would be, now potential, if we see what is potential due to this sphere, if we have to write potential for a sphere is given as kq by r, right? Kq by r. Now as we can see that potential is proportional to charge as well as it is inversely proportional to the radius. As you can see over here, more is the radius, less will be the potential. Less is the radius, your more will be the potential. So which option will come? Option number 1 say more on smaller sphere, equal on both the sphere, dependent on material of the sphere, more on bigger sphere. Basically the one which has smaller radius will have more potential. So option number 1 is our correct answer. Next is the angle between the electric lines of force and equipotential surfaces. Theoretical question, and it's a factual information which we should know, that equipotential surface, your equipotential surface are those for which electric field lines are perpendicular. That means the angle is 90 degree. If this is your equipotential surface, the electric field lines will be perpendicular to it. So our answer will be option number 2, right? Yeah. So the question that we have is, it says two charged spherical conductors of radius R1 and R2 are connected by a wire. Okay. Two charged spheres are there having radius R1 and R2 are connected with the help of wire. Then the ratio of surface charge densities of the sphere sigma 1 by sigma 2 is. How to deal with it? This is a question of your potentials, equating the potential. When the two spheres will be connected, the potential of two spheres will become equal. The potential of two spheres will become equal, right? Let's say over here charge is q1, over here charge is q2, right? Generally, what do we write, beta? Potential. Potential is written as, for a sphere, potential is written as kq by R. This is what we write. Now over here they are asking us charge densities. That means sigma 1 and sigma 2. So let us first convert this formula into charge density. How can we convert it? This is your K. Q value. What is Q value? Q value will be, sigma is given as Q by area. Q by area. So Q value will be sigma into area. How much is area? 4 pi R square divided by R. Right? This K can be written as 4 pi epsilon naught. 4 pi cancel out, r cancel out, so potential comes out sigma r by epsilon naught. Now you can keep the result in this terms also, you can keep this result in mind in terms of your charge density. So now let us write down potential of first sphere. What will be potential of first sphere? Sigma 1 r1 by epsilon naught. Potential of second sphere, when they are connected with the help of a string, the potentials will become equal. So sigma 2 r2 by epsilon naught. Epsilon naught cancels out. Sigma 1 by sigma 2 comes out. R2 by R1. R2 by R1. This is our answer. Option is, check the option, option number 2. Yes, option number 2 is our correct answer, right? Let's move ahead. Yeah. So our question is, 27 drops of same size are charged at 220 volt each. Okay, like this we have got 27 drops, same size and a small drop. So let's take their radius as r. Let's take the radius as small r, and each one has a potential of 220 volt. V value is given to us 220 volt. Okay. Next it says they combine to form a bigger drop. Calculate the potential of the bigger drop. They combine to form a bigger drop. Let's say bigger drop radius is capital R. Find out the potential of the bigger drop. How much will be the charge on this? Let's say on individual, because all of them are identical, on individual the charge is Q. So total charge is how much? Q, 27Q. How much charge will come on bigger drop? 27Q, right? Let us write down potential on an individual smaller drop that they are saying. It will be KQ by small r. What will be the potential? This is potential on small r drop, the small drop. The potential on the bigger drop, which is V capital R, can be written as K, the charge on this one, 27, K 27Q by capital R. So that means 27KQ by R. Right now the thing is, we don't know the relation, how much will be the radius for the bigger drop. For that, what we will do, we know that all these drops are combining and forming a single drop. That implies the volume of the bigger drop must be equals to the total volume of the 27 drops. So volume of the smaller drop, 27 smaller drops, must be equal to volume of the bigger drop, right? So let's write down 27 into volume of one drop. We can write 4 by 3 pi small r cube is equals to 4 by 3 pi capital R cube. 4 by 3 pi, 4 by 3 pi cancels out. We get 27 small r cube is equals to capital R cube. When we will simplify this, this will get it 3 times small r is equals to capital R. How much is our capital R value? 3 times small r. Let us substitute over there. So VR is equals to 27 into k cube by small r, or sorry, capital R. Capital R is 3 times small r. 3 times 9. So VR is equals to 9 times k cube by small r. K cube by small r. K cube by small r is nothing but, for a single drop, the potential is 220 volt. Let's substitute. So 9 into 220, that will give us 1980 volt. Okay, 1980. Which option do we have? This is option number 4. Yeah. The question that we have is, a dipole is placed in an electric field as shown in figure. Electric field is given to you this way. This is our electric field, and this is plus q, this is minus q. Okay. In which direction will it move? Four options are given: left, right, and potential energy will increase or decrease. One thing is clear: bodies always move such that they tend to decrease their potential energy. If you leave a body, it will always move towards that, it will always move such that it will tend to decrease its potential energy. So your answer should be decrease potential energy. But which side, right or left? That answer you can give with the help of force analysis. If you notice carefully, on this plus q, over here the electric field, basically the field lines, the density of field lines are more, therefore this plus q will experience force towards right, and the minus q will experience force towards left. Very clearly we can see that force F1 will be, force F1 will be greater than force F2. Force F1 will be greater than force F2. Reason being that more field lines are there, electric field is more. Electric field is more. What is our force on charge? Force is equals to Q into E. If electric field is more, obviously it will experience more force towards the right as compared to the negative. On the negative charge, relatively less force will act. And therefore the charge will move towards the right side. So two options, right, second and fourth are giving us right, it will move towards the right, and the potential will decrease, the potential energy will decrease. That means it will be moving towards right and potential energy decreases. Option number 2, option number 2 is our answer. Yeah. So the question we have is, in a certain region of space with volume 0.2 meter cube, basically they are talking about some space where volume is 0.2 meter cube, some 3D space they are talking about. The electric potential is found to be 5 volt throughout this volume. The potential is constant and it is 5 volt. This is volume, that is potential. Next it says the magnitude of electric field in this region is. Now please don't jump to the calculation part over here. Don't jump to. Think over the language of the question carefully. What they are saying is, throughout this volume the potential is same. It's a 3D volume, and over here throughout this the potential is same. In which case do we have potential same? Spheres, think about spheres. In a hollow sphere, inside throughout the potential remains same only, kq by capital R, and potential is same, whereas electric field is what? Zero. Electric field throughout inside is zero. So which option we will get the magnitude of electric field in this region? It will be option number 2, 0, right? Yeah. We have question. A short electric dipole has a dipole moment of 16 into 10 power minus 9 coulomb meter. Dipole moment P is given to us, 16 into 10 power minus 9 coulomb meter. Okay. Next it says the electric potential due to the dipole at a point at a distance 0.6 meter, some R is given, 0.6 meter, fine, from the center of the dipole situated on a line making an angle 60 degree with the dipole axis is, fine. It is given to you this thing, minus q plus q. This is your dipole axis. Some point P is present at a distance of R, which is 0.6, and this is making an angle of 60 degree. Basically, this is a question of electric potential due to dipole at a general point. What is our result? Result is Kp cos theta by R square. Kp cos theta by R square. This is the electric potential due to dipole at a general point. Let us substitute value. 9 into 10 power 9. P value is given to us 16 into 10 power minus 9, right, into cos theta. Cos 60 will be 1 by 2, and our R square, R is given to us 0.6, that will become 6, that means 36 into 10 power minus 2. I have square it. So how much are we getting? 9 4 times, 4 times, 2 times. So V is 2, and this is 10 power 9, 10 power minus 9 cancel. So we are left with 2 into 10 power 2, that is your 200 volt. 200 volt is our answer, right? Yeah. So our question says two metal spheres, one of radius r and other of radius 2r, one of radius r, other of radius 2r. Both have same surface charge density, okay, sigma and sigma. Let's say charges are q1 and q2. They are brought in contact and separated. They are brought in contact and separated. What will be the new surface charge densities? When then they are separated again, what will be the new surface charge density? Sigma 1 and sigma 2. Fine. Now initially what is given to us? Initially it is given to us, they are brought in contact, yeah, sorry. So initially it is given to us that their surface charge density is same. Surface charge density is same, that means we can write q1 by 4 pi r square will be equals to q2 by 4 pi into 2r square, 2r whole square, that means it will become 4r square, है ना? So 4r square cancels out, we get 4q1 is equals to q2. 4q1 is equals to q2. If let's say the charge on the first one is q, the charge on second one will be 4q. Total charge on the spheres is how much? Total charge on the spheres will be q1 plus q2 will be 5q. I hope this point is okay. Total charge is 5q. When they are brought in contact, whenever spheres are brought in contact, the charge will redistribute such that the potential becomes equal. When they are brought in contact, the charge will redistribute such that the potential becomes equal. That means V1 will be equals to V2. Now let us say that their charges becomes Q1 dash and Q2 dash. Earlier I said Q1, Q2. Now I am after bringing them in contact and then removing, separating them, the charges becomes q1 dash and q2 dash. So what will be happening when they are brought in contact? Charge redistribution takes place such that potential is same. If potential is same, so what can I write it? K q1 dash by r is equals to k q2 dash by 2r. K cancel, r cancel. What do we get it? 2 q1 dash is equals to q2 dash. Finally, the charge will redistribute in such a way, right, that the charge on second sphere will be 2 times on the first sphere. What is the total charge that we got it? Total charge is equals to 5q. So from here I will get it q1 plus q1 dash, and total charge will be 5q only. So q1 dash plus q2 dash. In place of q2 dash we can write down 2q1 dash. This is equals to your 5q. How much do we get it? 3 times q1 dash is equals to 5q. That means q1 dash is equals to 5 by 3q. This is what we got it. 5 by 3q is the q1 dash. Now it is simple story. If q1 dash is 5 by 3q, q2 dash will be how much? It will become your 2 times of this. So we will get over here 10 by 3q. Right, it will be your 10 by 3q. Now if we find out the charge density, so sigma 1 will be q1 dash by 4 pi r square. Q1 dash value is 5 by 3q. So 5 by 3q into 4 pi r square. What is your q by 4 pi r square? Q by 4 pi r square is nothing but the initial charge density. It is the initial charge density. That implies your sigma 1 will be 5 by 3 sigma. Sigma 1 will be 5 by 3 sigma. And similarly, if we calculate your this sigma 2 I am doing it over here. Sigma 2 will be q2 dash by 4 pi into 2r whole square. That will be your 4 times. Let's substitute the value. So q2 dash value, how much we got it? 10 by 3. So 10 by 3q, 10 by 3q into 4 pi r square into 4. If we cancel out, we will get 2 times. This will be your 5. So ultimately this q by 4 pi r square is sigma. We will get 5 by 6 sigma. Sigma 2 is 5 by 6 sigma. This is our answer. These are our answer. 5 by 3 sigma and 5 by 6 sigma. Right? Fine. I hope you understood. Let's move to the next question. Yeah. We have come to our last question. The last question that it says is, the diagrams below show regions of equipotentials. Okay. The positive charges move from A to B in each diagram. They are talking about the work done. In which case work done will be more or work done will be less, है ना? Or whether it will be equal. How do we find out? Equipotential surfaces are given. So work done is basically Q into delta V. Work done we write as change in potential energy, which can be written as Q into delta V. That is charge into change in potential. Now over here, if you look at all the 4 diagrams, in the first diagram, equipotential planar equipotential surfaces are there. At A, the potential is 10 volt, 10 at B it is your 40 volt potential. In second diagram also, in second also 10 volt to 40 volt, in third also 10 volt to 40 volt, in fourth also 10 volt to 40 volt. Just the difference is the shapes of the equipotential surfaces are different. In the first one it is your planar, in the second one it is curved and straight line, in the third one again it is planar but distance is there and separation is different, and in the fourth one it is your kind of a spherical nature is there. Okay, now in all of them, from at A point and B point, your potentials are same. Potential is same at A point, in each one of them potential is 10 volt, at B point in each one of them potential is 40 volt. That implies for all of them we will get Q into final is 40 minus 10, which will give us 30 Q. This will be the work done whenever a charge of Q is moved from A to B, a positive charge is moved. So this is what will be the work done in all of them. So what is our answer? Answer will be 1. In all the 4 cases the work done is same, right? Okay, then so with this we have completed our electrostats PYQs. I hope you found this video helpful. If you found some value from this video, do consider to like the video and subscribe to the channel. Thank you very much. Bye bye.